had any more than that. Well, Dawson, he was also a physicist and a medicine man as well in France, and he developed this meter, but the real use of it was really defined by Edward Weston you must have heard of Weston meters, and it was he who really refined this to the modern moving coil and all the varieties that we know these days. There are various types of meter which spawned from the early days. There's one called the moving iron meter. You find those these days in the common or garden battery chargers, which you get from wherever you buy battery chargers with the little meters. They're robust, somewhat inaccurate, but for battery charging in car batteries, you're not chasing the milliamps. You want to know whether it's amps or a bit less or whatever. And it's also a cramped scale. They start off being very cramped at the lower end and they open out as the scale expands. Well, when you're charging batteries, you're really only looking at the far scale anyway, so it's a nice big area at the bottom end where it's very cramped, you're not really interested in. So moving iron meters are commonly found in things like battery chargers, and it wasn't that one, was it? It was that one. That one. This is a commercial application supplied by Derek of a panel moving iron meter. And when you look at it, you see that, if you can, the first half an inch of scale, I have been converted, so I'm still imperial, is half an amp. 1 amp is nearly full scale, but from half scale, but from half scale to full scale, it goes from 1 to 12 amps. So again, it's a non-linear scale, but for its application, it's fine. How they work, there's two means in which they work. The first is a solenoid wound and a piece of iron inside the solenoid. And as the current is increased, so the solenoid pulls the iron further and further into it, and it's coupled then to the meter needle of the scale. Or the other type is where there's two separate iron veins, one of which has a coil around it, and the two veins are linked. Okay, linked. But as the current flows through the one iron, the other vein also takes the same polarity. We know that like charges repel, and so the veins open up and show how show the indication on the meter. Another type of ammeter, I've never come across one, but I know of its existence. It's the hot wire ammeter. Have you ever come across one? No. The hot wire ammeter is a piece of wire strung between two terminals, and it has coupled to that wire the linkage to a needle, and as the current flows through the wire heats up, and the tension on the needle puller it allows it to sag and alter the meter. And when it cools down, it tightens up and puts the needle back to zero. I've never come across one in my calibration life, which has been a year or two, but I know they exist. The most common one is the moving coil meter, which is going round, as you know, in that form there. Another variation of the moving coil is the dynamometer meter, of which this one is a dynamometer meter, and the company that I was working for a long time, Emerson Electric UK, our test bays were equipped with these, and right up until the company finished 1999, I was asked to leave a bit before then. These were still being used in the test bays, but by then they weren't solely used. They were using an electronic version as well as these. These are reasonably robust. The majority of the repairs that we had to do on these was to replace the glass because Emerson Electric made UPSs, uninterruptible power supplies, big ones, up to 680 kVA in a single unit. That's a lot of power. Consequently, the cabinets are big. Some of the test engineers matched that in size as well, and they always used to carry big spanners. And the rest of it is like you can work out yourself. Spanners through the glass was a regular occurrence. I usually used to get one of these a month anyway. So I used to carry a good stock of glass already pre-cut to replace those. Unfortunately, not every time, but when the spanner went through the glass, if it went straight through and hit the scale, I was happy, because then I just clean up the bits and put a new glass in. But unfortunately, if the needle was part way across and the spanner hit the needle, then there was a bit of work to do. And the mechanism inside, in fact, is a work of art, as some of these other ones are. It has an air damper. The pointer comes out on a V, expands down, goes onto a device. I'm going to draw this in the air. I'm not going to draw it now. And in the air. Needle. An A-frame. That was welded to this anchor portion. On the end of the anchor portion were two aluminium cups. The pivot on this is somewhere about there. And these then ran inside a moulded bakelite tube, which was the air damper. So this thing moved, and it controlled the movement that way, or it controlled the movement when it swung back, so there was no violent excursions with this. And all this was made with aluminium, which was around 10 thou thick. And big spanners and that thickness aluminium don't go very compatible. So if they were damaged, I had to hold up my hands and they had to go back. But usually repair most of them. What it does, instead of having a magnet to assist the operation, it has an electromagnet as well as having the coil. And so these meters will operate on both AC and DC, and with the appropriate connections, volts this side, amps that side, it will measure watts directly. And in our power supplies, measuring watts was a very important part of the testing. Mini lecture, I'm not telling you any more. If you want to know more, you can ask me afterwards on that one. Electrostatic meters was another one, of which Derek has given me one there, but I will show you another one here. Be a little bit careful with this one. And these are quite interesting meters in that they don't use coils or magnets. They have in them what looks like a capacitor. Vanes of capacitor. Vanes of thing with pointer on it, pivoting. When you apply voltage, if these work at higher voltages, I was quite surprised with, there was I think that was a 400 volt one, which is the lowest I've ever come across. Derek's one is 2000 volts. It is simply the electrostatic lines between the two sets of the capacitors. Here, it's a precision instrument, these. So the lines of force will cause the plates to rotate, the moving plates to rotate and give a direct reading on the pointer as to what the voltage is. That's an electrostatic meter. Reasonably common. but really not in amateur radio, that's more of an industrial type of instrument. There is another variation too, which you find particularly in Russian multimeters, where instead of having pivots and screw cups to adjust it all, they have a taut band. And if you see on some instruments, it does say in fact taut band instruments. They're rather nice. The coil is suspended on a ligament, a metal ligament, and anchored to 2 points. And it's under tension, a little bit of tension. It would be like two fixed places, a little bit of phosphor bronze springing, and then the meter, should be a bit further down, is strung between those two like that. Now, in fact, I've drawn that rather foolishly round the wrong way, haven't I? Who spotted that? Right, no one gets any points for that, no? It should be like that, so that they're trying to stretch the taut band. It's trying to stretch it out. And this makes really a frictionless movement. It's only suspended by that ligaments, and they're quite strong and robust. Also, if you bought some of the early Russian meters, when they started to come onto the market, they even packed in them a replacement taut band so you could restring them yourself if you did naughty things with them. And then we come on, the next development, of course, is what we are quite familiar with these days, is the digital multimeter. The early digital multimeters, I was fortunate, I suppose I was in the right place at the right time at the right age, if you like. I was working at Plessy at the time when the first digital multimeter actually came into the company, and it was used by the calibration section. It was made by Advanced Instruments. If you're not familiar with them, I think no longer exist making instruments, but they were a well-known and quite reputable instrument company. They made, if you like, middle-of-the-road instruments. They weren't high precision, and they weren't rubbish. And this thing was about 18 inches wide, a foot high, and about 8 inches deep, and it had 4 windows on it for the digits, and every one was on a galvanometer inside and projected. So it was an electromechanical digital multimeter. But it didn't last very long before the electronic displays came in, and of course the electronics associated with that meter then became transistors. I don't think there was ever a valved one.
Were there Nixie tubes? Were they not?
Oh, no, that was only the display. I'm thinking of the bit which makes it work.
Oh, right.
Yeah, the Nixie tubes, yeah, that's the display. Nixie tubes, they're gas-filled or neon display ones.
HP made some valve.
Did they?
I think so.
Oh, I've never come across it. I suppose at that time I wasn't working in that class of factory. It was still presses. Okay. And then it became transistors and then discrete devices, well, VLSI, very large scale integration. And as the meters and as the VLSI was developed further and further, so digital multimeters had more and more functions added to them. Now then, if you go around to a rally or somewhere like that and you're thinking, I'm going to go and buy myself a meter. This doesn't have to be multimeters, it can be single meters. You might want to know what you're going to buy. And so from Dennis's crib sheet, give you some idea of what the markings are on some of these meters. So children,
Can you see this?
Sorry?
Eye test.
Yes, okay. Right. The top one. I will ask if anybody has any suggestions. If you know it, don't say. Top one. Okay, it means the meter should be used in the horizontal position. That one, from what I've just said, exactly, it must be used in the vertical position. So that's the sort of thing you use on panels. The star, well, I've put 2 inside it.
Voltage
Space.
limitation?
It is voltage, but, sorry,
Maximum voltage across?
no, it's actually it's the flash test. Flash test. DC operation, of course. AC operation, although often it's not said what the AC operation is, whether it's a rectifier instrument or whether it's other means. That one? Ah, yes, a capacitor. But we've already covered this thing. Thank you very much. Yes, give up hand, praise. FE written on the scale.
Moving iron.
No, not moving iron. Nearly. It means it's calibrated for use in an iron panel, or iron or steel panel.
So therefore,
And aluminium is calibrated for aluminium. And then you get moving iron, moving coil, TC, thank you, thermocouple instrument, 2% FS,
accuracy level.
yes, 2% of full scale deflection. Good, there you are. It might give you some idea of what you might be chasing. And just to show off, you see, on my AVO meter, this is on my AVO meter, on the scale, it's got a few things like that. And this is although it's jokey, I know, this could be useful to you if you're going to buy an AVO meter. Mine has got those various bits on it, but it's also got Model 8, this is a Model 8. Number 121975C561. Now, what that means is that this AVO meter Model 8, this is the 120,975th one made. The C is week 3, 5 May 1961. So it gives you a straight thing as to when the meter was made. So if you're at the rally and you see one which looks interesting and you might want to buy it, well, just check it out, you know when it was made, and you get some idea on what it could be like or what it's been subjected to. Right then. Now then, we'll go down to how are we doing? Not too bad. The next bit we've put in as meter specifications. The first bit, analog. Sensitivity, ohms per volt. And demonstrate using the ohms box. Do you want to see the demonstration now amongst you, or do you want to see it at the end?
At the end.
Okay.
Let's go for it.
All right, okay.
Have a
Well,
break.
This is a demonstration. The explanation will follow in a minute. It is important, especially to us radio amateurs. There's nothing daft, funny, hidden, or anything like that. Anybody confident in reading an AVO meter within about 8 feet of me?
Jeff, you're at front, you can read it.
Thank you.
Progress.
There's nothing daft about this one. Okay.
By the way, it's 3,000 volts, Jeff.
Oh yes.
Getting glasses in focus.
Right, okay. It's switched to the 10 volt range.
We're on there already.
Yeah, that's it. You're reading off the 10 volt now.
DC 10 volt.
DC 10 volts, that's it?
Horizontal.
Right.
There we go.
Yeah. Dennis is a voltage standard, this is. So I'm going to plug that into there, and I'm going to plug that into there, and it says,
Oh, golly gosh. 9.5.
yeah,
9.8.
near enough.
9.8.
Yeah. Can we have that 10 volts? Yes.
Six.
Yeah, okay, cigarette, yeah. That one,
2.4.
okay.
2.469.
Now that was the sort of thing that you would find in valve wirelesses, maybe car autos and that type of thing. What this is, there's a string of resistors of radio values. Now, I've gone over to the transistor circuit impedances now. This line of resistors is somewhat higher. So, you go in there.
9.8.
Yeah. Into there, halfway,
Gosh, 3.3.
and a quarter of the way.
1.8.
Ah, why isn't it 2.5? Oh dear, what fault have I got? I'm applying for a grand brand. Thank you very much. So, what does this tell us? Well, it says that there's an area of thought here. Now, on this Beckman industrial instrument here, I won't go down the radio auto side, but I will go down the transistor side. That one. Plug that into there. Plug that into there, and it reads, if you can see, 10 volts. I go halfway down. 4.97.
That's because you use
That-
that to calibrate
That's
it.
pretty well halfway, below halfway. And down there, 2.49. So this one reads right according to what the resistors are. And the area of why is it? Well, do we know? Well, we do know, of course, because we're radio people. It's that the sensitivity of the old moving coil instrument is, it's reckoned at 20,000 ohms per volt. What that means is that at 10 volts, it presents to the circuit 10 volts, 200,000 ohms. That's what it presents to the circuit. Well, the resistors down that side I've selected at 10k. So each resistor is being shunted by the meter at 200k, which is not a lot of change, is it? So it will read right voltages. However, on this side, I've got a string of 100k resistors in, and it's being shunted now by rather close to its original value, to those values. And as the meter consumes power to operate, it's going to shunt those resistors and give you the odd answers. And the reason for telling you this is that when you're servicing equipment or looking around for circuit faults, it is well to know that analog meters consume power from the circuit under test to operate. But we notice that the digital multimeter doesn't. It's because the input impedance on that is around 11 megohms, and shunting even those 100k's, it's virtually no change at all to that. And it consumes virtually no power, and to power itself it's got an internal battery. So what am I telling you? What I am telling you is that analog and digital meters do have different applications. If you're going to start out your workshop new, which one are you going to go for? Well, I suppose everybody wants to go to digital, and if you get a reasonable digital one, you've got a good start. However, this sort of thing becomes quite significant if you're doing what I do in Summiters. If you don't know, I do repair valve radios, and most service sheets have marked on the service sheet all measurements taken with an AVO 8 and at 20 or a similar meter at 20,000 ohms per volt, and so that the table of voltage values given on these service sheets are appropriate for that. If you went for that one, you would get different answers. It's well to know this. The other difference is that to measure ohms with the analog meter, you've got to have a voltage source. And in the AVO, as some of you will know, there are in fact two batteries in that one, because there are three ranges. The two lowest ranges use one battery, and the other range, the mega range, uses a 15-volt battery.
Some of which are now difficult to get by.
Very
Yes, they are indeed, yes.
Gold dust.
On the digital meters, its own internal battery takes care of all those types of measurement. A little bit of background for you on that. On the digital one, ohms per volt is typically megohms per volt. And we don't say much more than that. It's very high impedance and it doesn't soak the circuit under test. It also has the same sensitivity on all ranges. If you change the ranges on here, then the sensitivity changes. That can cause confusion as well. And there's one of it too which I put in. This is one which how the salesman treats you, the salesman's tongue, the silver tongue. These meters, the AVO meter, I'll read off what it says on the scale, it's quite clear. It says that its accuracy is, on DC, 2% of full-scale deflection. If you're measuring Granny's trolley batteries, you want to know if they're over 6 volts. You don't want to know that they're 5.1372 volts. You just want to know it's above 6 volts. The radio's going to work. And then it says on DC current, it's 1% of full-scale deflection, because basically it's a current meter. And AC, it's 2.25% of full-scale. So it's not bad, really. It's not bad. And for valve circuits and auto-electrics, that's more than adequate. So I copied this one out of the RS catalogue, and you get this one here, DC accuracy, plus or minus 0.2%, this is digital, it's reasonable, what you want, plus and minus 20 counts. Now just have a think what that means. Or you can go to another one over here. This one is plus or minus 2% DC accuracy, plus or minus 150 counts. There's another one here, 0.37%, plus 100 counts. What that's telling you is that when you go and put this meter onto a circuit, it says that it's reading 10.00 volts. Actually, I'm maligning Fluke, it was very good. But one of the other ones, and it reads 10.00 volts, but it also could read 10.1000. It was a plus 100 counts. You've got to be aware of specmanship. You really have got to be aware of that. Read the book. Yes, but I stand down to it. Thank you. Yes, and understand the book. Yes. Yeah. Okay, how are we doing? Yes, we're still in the mini top range.
It's now a Cooper.
Pardon?
It's now a Mini Cooper.
Yeah, yes, it is. Yes. Right. This bit was I put down as safety and operation. Going through it fairly fast, it's quite deliberate. Meters, protection. Meters, some have fuses. The digital meters certainly have fuses. The Fluke one, there's stories on this. I will tell you, but I'll just cover the other bit first. These meters also have fuses, different from those, but still have fuses. AVOs don't have fuses, but they do have a cutout. This button there is linked to the whole meter movement, and if that pointer bangs over a bit fast, it hits a trigger, and this thing springs out and breaks the circuit completely. Now, in all my time, sorry, I'm sounding like an old boy here. In all my time servicing, repairing and calibrating instruments over the last 40 years, I've never encountered an AVO meter which had actually been damaged by overload. That's a flat statement. That velocity trip really works. These meters, the flukes particularly, also have in the front end a fusible resistor as well as the fuse. It's a 1K resistor which is directly in the measuring circuit, and the rest of the circuits are compensated for that 1K. And if that sees something it doesn't like, the resistor just melts and opens the circuit. Now then, the horror stories. We did have a bright engineer who was servicing one of the pieces of transistor test equipment at Plessis, a big American Fairchild system. The power supply wouldn't do what he wanted to, so he held the button down, and that one I did have to repair. The DC voltage multipliers are on a card just inside there. They're wire wound and wound individually on this one long card. And he managed to toast the whole lot. He wasn't popular. He became very unpopular with the management after not too long. Now, this is the horror story. This is for real too, and why I can always recommend Fluke. When I was at Emerson, we had on trial some Philips meters, and these were the handheld meters. Nice meters, but they had a feature on them which ruled them out forever from Emerson after that, is that the 10 amp range on it was a straight piece of metal inside. There was some sort of current shunt inside. One of our test engineers went out on site, and UPSs have a DC bus bar in it. It runs at 350 volts and is virtually unlimited amps for a second or two if anything goes wrong. And he was taking a measurement voltage reading across this. I'm doing this because this is how the system was. The test point is up there, the earth is down there, and it goes across the bus bar on the voltage range. Yep, 350 volts. Just check the current through it, and without thinking, he didn't change ranges, and he just went, well, he did change ranges by switching it to current. And he put this straight across the DC bus bar, across that shunt inside. Well, he brought the meter back, and it just sort of rattled. And when I took it was like a walnut inside, and that's all there was left of it. On another occasion, a different engineer, similar situation, he did the same. This was a lower down one. He went on current again, in like that, and it caused an arc before the thing exploded, and his trousers, just there was a patch through the metalwork in the UPS, and he had brown trousers on, but there was a square panel in the front which was very, very low for the UV light. And he was in hospital for 7 days with all the metal burns up his arms. And these are not, I know it's funny now in retrospect, and both guys are okay now, but at the time it was flipping serious. That was a Philips meter. Right, we have this situation, and my head of department, one Brian, said, this is serious, we've got to do something about this. What meters do we use? So I said, well, we use AVO, Philips, Keithley, what was Fluke. Did I say Philips? We use Philips. He said, right, he said, we're going to see which ones are going to be safe for our application. Please understand that. UPSs of huge amounts of current under fault conditions. And so I wrote to all the 5 manufacturers and said, this is our situation, will your meter withstand these problems? Avo replied and said we don't want to take any responsibility whatsoever. The other 3 didn't reply at all, and Fluke said, we'll bring a meter down with an engineer, you can do whatever you like with it. And we did those tests where we had the other accidents, and the current protection and the fusing in these is absolutely magnificent. By Fluke. From then on, the company standardised on Fluke. We had the bench meters, we had 120 of them because the protection is similar to the handheld, so there's about 98, that sort of thing. Never had a problem ever.
And that was no Fluke.
That was no fluke.
That was fusible resistance. Right. If we want to measure big currents then, and to measure current in one of these, it's a piece of wire about 1 inch long, and they scrape it to the right resistance, and so the meter reads say 10 amps or 20 amps in this 20 amp range. If you want to measure 100 amps or 20 amps or whatever, you have to use an external shunt. And here is an external shunt, the sort of thing that you couldn't put inside the meter. And what you do, you connect remember, to measure current, you've got to break the circuit. So one wire of the circuit goes on there, where that one went, the other one carries on round there, and you connect your test meter to the 2 horns on there. And if you're using Avo leads, it just so happens that those 2 horns are just the right size. You see, if your Avo leads just to plug onto them, and that then goes back to the meter. Select the appropriate range, and you can measure high currents using that method. What is used inside the meter are little shunts, this sort of thing. And this is a 10 milliamp one for a precision meter, so it's a bit big. Others in there are a bit smaller. There's another means too of measuring current. There's a current transformer, where if you've got a meter which measures AC quite happily but is limited range, you can connect the current to the appropriate terminals and put your test meter on there, and being AC, it will only work on AC of course, the meter will respond to the settings on these current transformers.
Using gas quantities in the electricity supply.
Absolutely. An interesting point, as was demonstrated once accidentally at Emerson, I was only an observer. Current transformers like to be loaded. They have to have a secondary connection to them, and if they don't like it. They tend to catch fire.
Must be short.
Oh, yeah, short. English, yes, short. They tend to catch fire if not. So you're unlikely to come across that in amateur radio. Multipliers, the resistors used in Flukes and in 1 or 2 other makes are nowadays etched out on a ceramic surface in a pattern, and then they're trimmed exactly with a sandblasting machine, all automatically, to the right values. And it becomes a string of resistors, rather like my homemade box here, and then the switching unit just taps down these resistors. If you happen to look inside one of these meters and you see if the resistors are made by a company called Caddock, you know you've got a reasonable meter there, because Fluke use a lot of Caddock in their production. They're good standard resistors. And some of the cheapo meters also use Caddock. Quickly, transporting a meter, analog meters always switch it to a current range, preferably the highest current range. It effectively puts a short across the meter when you select the nose.
On the Avo, it doesn't the off position.
But on the off position, it does exactly that. But my Avo hasn't got an off position because it's an old one. So I just put it across the 10 amps DC, and that then damps the meter. You can move the meter around and it doesn't do any damage. Right, just one or two makers then to bit of nostalgia for some, and ones that you can think of if you're going to go, you want to buy a meter. Avo, good English company, still produce digital meters, one's quite good. Fluke, probably the best. The Fluke do a standard meter, and that is a true standard meter, an 8-digit meter, which is used by standards laboratories. These are national standards laboratories too. And the electronics involved is very clever and patented by Fluke, and excellent company. Hewlett-Packard, now renamed Agilent. We don't, us in the trade who knew it was Hewlett-Packard when it was Hewlett-Packard, Agilent is definitely an anagram of genitals. So they make some good stuff. Japanese ones, have you seen TMK? Yeah, they're okay. They're okay. Yeah, they're okay. Robin. Now Robin is now taken under the Fluke wing, so they've got to be reasonable. But you find those more for electricians and autos. Keithley Instruments, they do some curious meters. If you see them, if you see one at rallies, it's always they're always worth a second look. But they do measure things like fractions of microamps in some versions of it. They're very, very specialist inside. But they also do some auto-ranging bench ones now. Quite good. Hung Chang, that's one which you do see around a lot. And that's another cheapo Chinese one which uses the cathode resistors. And we bought a few at Emerson and we never had trouble with any of them. We just went on and on and on. And others if you want to add in. That's multimeters.
Simpson.
Simpson, yes. Yeah, okay, yes. Yeah, I forgot Simpson, yes.
Taylor?
Taylor.
Taylor is Avo. Well, Taylor was Taylor, of course, at one time. Experience, I had trouble with those, mainly on the actual resistors, not on the movements, but the standards used to drift. When it comes to ordinary power meters, who remembers Ernest Turner? He was a radio amateur, of course, and he had Ernest Turner instruments at High Wycombe. Westerns, of course. BPL, British Physical Laboratories, they made some good ones. Raycal used a lot of their stuff, but in fact they bought the company in the end. SEI, Salford Electrical Instruments. Ferranti. General Electric. Of course, the modern one, UK one, still churning about by the thousands is Sci-Fam at Torquay. They make some very nice instruments too. And there may be others. Down to the uses, mini lectures. To measure current, stating the obvious to some but not to others, I know this, current measurement, you've got to break the circuit and put the meter in series with it. I was working for Plessis, and there was an electrician there who was a bit of a wide boy, who, having received from our section a power supply which we repaired for him, he said, I would just go and check it over, and I took it down. Just go and check it over. Out this test meter, volts. Yeah, 10 volts, that's fine. I'll just see how many amps there are in the power supply. Switches to amps and switches straight across. And he didn't know what he was doing. Measuring amps. Yes,
A lot of amps.
they are out there.
The power supply is great. Can you take the meter now?
Okay.
Yes.
Although having said that, I agree totally with you. Having said that, there are some circuits that own bells which in fact measure volts across the picture resistance.
Oh yes. Yes. But then it's designed to do that. Clip-on ammeters. They are around. In fact, you see them quite a lot nowadays, particularly for auto work. And they're both AC and DC. The type which I was brought up with early on was AC only, because they were a transformer which you clip around the lead. But the later ones, if you see that the name is HEME, H-E-M-E, which stands for Whole Equipment What's it called?
Hall effect.
Hall effect measuring equipment. That's it, Hall effect measuring equipment. And they do AC and DC just by clipping it around the wire.
It's a nice little transformer, so but on multimeters the same.
Yes, they do. Yes, they do indeed. RF measurements. Now, as we're radioing people, how do you measure RF with a moving coil meter? Well, the answer is in this little meter I have here. Please be aware, I've taken the scale off, but the needle is still free and exposed. If you do break it, don't worry, but I prefer that you didn't. Inside there's a glass tube, which is a thermocouple. And how this meter works is that you apply the signal current through it, which is radio frequency, but it can be DC, low frequency AC, but for RF, we're radio now. It flows through that little device in there, which is a little heater, and attached to that heater is a thermocouple. If you've not come across thermocouples, it's two dissimilar metals welded onto that little bit of metal. And as that heats up, it generates a little voltage, a little current, which then operates the meter. On those you'll see the scale follows. It's very cramped at one end. And again, it's a similar sort of argument as to the moving iron, not for the same reason, but the device generates more current at the hotter end. And the thing is with those, don't overload it. If you do go over by about 5%, you're in the danger zone. If you're about 6%, it's dead. They do not stand overload. I've told you about the accidents. Show you, analog and digital. We covered generally the views of analog and digital. If you're going to carry on your workshop, have one of each. Chasing faults around circuits, particularly on radio, valve radio and that type of thing, the AVO meter is king. But the digital comes very much into its own on the setting up. When you want to do the final settings, there's nothing to touch them, that's what you've got to go for. So if you can afford one of each, have one of each.
The one time when the analog meter beats the digital meter, of course, is when you're looking for changes.
Yes, change indeed. Yes.
Doing mag curves, for example, but there are some other things as well.
Well, even like IF alignment,
Yeah,
where you're doing it there.
Okay.
On these, all you see is a string of digits going round, and you can't follow what's the trend on the meter for doing alignments.
Those flukes seem to be a lot faster than others though.
They are,
On the
agreed.
display update.
Yeah.
Way to make the flukes faster, get range stepping. If you step it to the range you want instead of an auto range, it'll be quicker on that range as well.
I found it picks up on the auto faster than any meter that I've used as well.
On the auto, yes.
On
yeah,
the
it's
auto
fast.
range, it's just, it's done.
But if you know where you are, so it's not
Oh,
stepping
yeah.
into that range. Yeah.
To cover very briefly, we're almost at the end now, test leads. Now AVO do provide, with their AVO 8s, these test leads and test prods. My view, they're useless.
I was going to say they're terrible.
They're horrible.
Meters are both ends are terrible.
Yes. They're too big, don't grip where they should, spring off, get in the way, whatever other combination you want to put. I do not like those. However, if you go and make up your own, these Hirschmans,
Yeah, they all come nicely.
those hook on very nicely.
Problems with the AVO do have the small ones that come out of the
Yes, they do. Yes,
always fall apart.
yes, they
As well as just
do.
the verticals.
Yeah. Yes, those Hirschmans rarely go. They do go wrong, of course, but the AVOs tend to go wrong a lot.
You had to recalibrate the meter because of those.
Yeah, I believe that.
I'm saying, did you have to recalibrate?
No, but I have heard instances where the AVO ones, they get worn inside and they make poor contact down the tubes. And, well, lastly, that's really the main body of what I was going to say. Questions and all afterwards, if you like. Just one or two bits. I brought along a couple of standard meters. I know that people, there's comments here tonight, oh, I got some of those, one or two people, also, I have also. You all see a work of art, it's one of these. I'll just read this. This is a centre zero meter. Okay. It's 5 microamps either way of centre. It's hand calibrated, and it was done on January the 4th, 1960 by Mr. Welford, it looks like, and certified by Mr. Sugar at Sangamoor Western. And when I took this out of service quite a few years ago, it was still in cal. Beautifully engineered. And my head of department said, well, we're all going over to AVOs and that. He said, skip them, I don't want them. So I couldn't do that. And similarly so with this one, skip it. The watt meters, well, they were going over to electronics, so they were out in the skip. So I just gathered these up and kept them.
That should be a hanging fence.
Well, I think it's something it should be. What you're seeing here with those is only a little bit of what I did get. Not only multimeters, I've got potentiometers, the special resistance boxes and all things like that. Just an example of an early little AVO. And really, that's about all I'm going to say tonight. I'll give you the Oersted's demonstration if you want to come round in a minute and have to see it. But, any questions on that?
That's a galvanometer there.
Yes.
Right,
Yes.
that looks pretty ancient, that one. What year do you reckon that is?
I would say that was around the turn of the century, about 1910-ish. Yeah, about that. I've not found any information on it, and I'm going to restring that.
That's a nice little instrument.
Yeah, it is.
It's a collector's item, that.
Yeah. Yes.
Yeah.
It was because it was broken, and it was a slightly sad one actually. I got it from the gentleman's wife after he died, and she said, "I don't want this. I know it's broken." He was going to mend it and hasn't, and so you can have it.
Yeah.
And I accumulated that with a few other pieces from the same source.
Nice bit of kit.
Yeah, it is. Yes.
Do you want to say about the AVOs, how they measure AC? Mean and average as opposed to like some flukes that do the RMS?
No.
It's a mini talk. It's a mini talk.
Go on, let's start me off.
Flukes don't measure, sorry. An AVO won't measure true RMS. It's a mean which is...
Oh, yeah, I
Fruit,
follow.
if you
Yeah.
like.
Oh, sorry, I follow. Yeah, I know what you mean now.
As some of the flukes don't measure true RMS, the modern ones like that do.
The hesitation in that saying that was that I didn't quite know what Chris was alluding to, but I do now. Yes, if you measure RMS on the AVO meter, because of the bridge rectifier and the rest of the search tree inside it, the needle doesn't follow, and it has to be calibrated at the appropriate range, really. And when it comes down to RMS, there's different types of RMS. You know what RMS root means? Square. If you've got a sine wave, it's quite predictable. You know what it is. But a lot of radio circuits don't generate sine waves. And consequently, you find that digital multimeters are available in true RMS. And if you find a true RMS one, it's going to cost you more because it has a
That was
different...
an RMS one.
But this is not. Oh, no.
The same stuff.
No, you want the 87, that's an 83.
It's on 87, yeah.
Yes.
But they say on there.
True RMS they do. That's for our use, yeah, some of us do. I actually have a true RMS one, not a fluke one, a Hewlett Packard. But I do use it for distorted waveforms. I want to know what the power is in the distorted waveform. Yes, sorry, I see what you mean.
Meters, you know. If you bind them around, if you want to know if they're working, that moves around, doesn't it? shorted out, it won't.
Yes,
It'll be damper.
good point.
To get your
Good
keys
point
out and
for
across
keeping
back. If it carries on moving, someone's going to have to give it something.
But equally, that's a good tip for storing meters. Because
Oh, yeah.
they're-
Okay.
Time round it,
Sure,
yeah.
sure,
moving around.
Well, what I've done with my Avos is when I'm not using them, I just go a shorting gun just goes across the top.
Mhm.
And that just shorts out the movement.
Going back to your RMS, if I can do an advert, the other way of checking on your RMS or peak is to use a scope, which brings us on to your next story.
Oh, it does actually. Thank you very much. Thank you.
Are you going to talk on scopes, are you then, Dennis?
Next one is surface mount, isn't it? Or is it? Yes.
You do.
Surface, next one is surface
Surface
mount. The one afterwards is I suppose.
Have we got any other questions?
What about these cheap meters you see at Macklin and the Rallies and things?
All right.
I mean, you see them for as cheap as
Yes.
£5.99.
You do indeed, yes.
Yeah,
They
but
were
what's-
selling them some. I did see it £2.50 at one time.
What's your view of those things?
We bought one. I was at Emerson, and we bought one to see if they give it to all the engineers, and they were okay. They were accurate enough, but robust, no. For UPS engineers, no way.
For any field engineer?
Yeah, well, yes, in any field, just be fair to them.
The flip ones, I noticed the leads you got. Are they? They're the shrouded ones.
Yes, they are.
Aren't they?
Yeah,
Supposedly safe when they come out.
yeah.
Sorry, no, these ones, the
Oh,
ones, sorry.
yeah, yes,
I got that
they
wrong.
Yeah.
The shrouded ones. From my experience, the damn things seem to come out. I like the ones that hook around the back. Well, you've got to be careful with the ones that hook around the back. If you're on something playing around with your mains or your valve and you do that, and the hook comes out, remember it's live. You know,
Yes.
It's not the shrouded cup type one. So one's safe when it comes out, one's not quite safe, but it does come out.
I understand the same engineer that brought down your fluke, if I remember the story correctly, proved that they also bounce.
Oh, yes. There was a Fluke's Model 73. That's one of the cheap versions. It's less than £100, rather less than that. And the basic, it doesn't have a case on it. It was just a meter like that. And the Fluke rep came in one day to show this brand new instrument off. Now, where I was working at Emerson, my bench was say was about here, and the end of the workshop was about as far as the end wall. And he said, these are very robust. He just threw it down like that. It just over, and it was perfectly all right. And he went on to sort of expound the virtues of these Fluke meters. They're good. And he said they had a guy in the States who dropped one off a 250 chimney stack, and it bounced.
What was he measuring? Lightning?
No, he was measuring the parcel.
Rubbish
coming out with the photos on. I didn't fancy his job. It was at a rendering plant. It must have been one of the gas masks on there.
I can't stand the tension.
Oh,
It's me or the meter.
yeah.
Just,
We got any other
just
questions?
a warning, there are lots and lots of fake Fluke leads around
Yes, there are.
on eBay. They're nothing like the quality of the real ones.
Planned stupidity. This isn't one against my boss. He knows bloke. Planned stupidity. He was always a hail fellow, well met sort of guy, and all bouncy, breezy. He was quite chunky with it. He was another one. He was in the back of the UPS, and he had his meter on it. Right? Saw what he thought was the end of the probe lead. Plugged it in, if any had the same lead going. The inevitable happened. There was an almighty bang. But of course, because he was the boss, there was no way was he going to admit that he was wrong. He had to go and put notes all around about what you had to do about before you had this and that, before you could take measurements, which everybody ignored.
What was he left with? 2 probes with nothing between.
Yeah. Yeah. All right.
Okay, you've got a demonstration in a minute.
Yes, I have.
We'd like to thank you very much for giving
Okay.
us a call.
Thank you.
Appreciate it.